Okay, guys, we've done naming compounds now, so I thought I'd do a little tutorial on writing formula for chemical compounds. So formula are something that students often get a bit scared about because they look really, really complicated, but they're actually not that bad. And again, there's a couple of simple rules, and if you follow those rules, you should be fine. So guys, I've put one up here already. So my formula for H2O just tells me that water has got 2 hydrogens and an oxygen. But let's go through the rules, alright? So let's go through a couple of simple steps you can follow to figure out those kind of things. So the first one, guys, a chemical formula, like this one, H2O, if it's got a small number in it, this tells you how many of the previous atom are in the molecule. So the 2 here tells us how many hydrogens are in it. In this case, we've got 2 hydrogens. And the oxygen, if there's no number, it just means there's one of them. If there's one of something, we don't bother putting in a number. So 2 hydrogens, 1 oxygen equals H2O. Now guys, if you've got something like that, it's usually the single thing that goes in the middle, and the 2 hydrogens kind of branch off it. So we'll draw it like that. So guys, little number tells you how many of the atom just behind it that you've got in the molecule. If you've got a big number, like this one here, the 3, that tells you how many of the molecules you have. So 3H2O means we've got 3 whole lots of H2O. Alright, so we've still got 2 hydrogens and an oxygen as a group. The 3 just tells us we've got 3 groups, so 3 of everything. Let's do an example. So if we were to draw these, the first one, carbon dioxide, CO2, and then the second example, 2CO2. So for the first one, how many carbons have we got? We've got 1. How many oxygens have we got? We've got 2. So let's look at our answer. You can see here 1 carbon and 2 oxygens branching off. Now some students go, oh, you drew the carbon smaller. Alright, so remember, now you probably wouldn't mark you down for that in a test if you didn't do it smaller, but you can check on your periodic table. Remember, the elements are in order of size. Carbon actually comes before oxygen. It's number 6. Carbon is number 8. So carbon is going to be a little bit smaller than oxygen. The 2CO2 just tells us we've got 2 lots of that. So here 1 carbon with 2 oxygens attached, and here it just tells us we've got 2 carbon dioxide molecules, 2 lots of everything. Okay, a couple more examples here. So NH3 and CH3CH3. Now I'm actually going to draw those in. Alright, so just like you would have to do in a test. So here nitrogen, let's draw a nitrogen. We've got 1 nitrogen and H3, 3 hydrogens. Cool, so there's my answer there. CH3CH3. Okay, well what it's telling me is I've got a carbon with 3 hydrogens attached. Hydrogen's a bit smaller than carbon. Okay, and then we've got another CH3, and it's all attached together. So that one's carbon, and my 3 hydrogens. Okay, my drawing's obviously not as good as yours would be. You can probably draw much nicer circles when you're not on the computer. But guys, there's basically your answers. So for those 2 there, this one NH3, 1 N and 3 hydrogens, 1 nitrogen, 3 hydrogens. Here CH3, CH3, we can actually draw it like this, C with 3 hydrogens attached to another C with 3 hydrogens around it. Okay, so guys, there's another 2 examples. I hope that helps you figure out how to do it. Alright, cool. Alright, now for these ones are getting a bit too big maybe to draw, some of them here. So for a question like here, it's a bit of a different question. I've just asked you how many atoms are in each of the following. So the first one here, alright, let's go through this. How many hydrogens do we have? So we've got 2 hydrogens, H2, hydrogen times 2, sulfur times 1, there's no number after sulfur, so 2 hydrogens, 1 sulfur. How many oxygens? We've got 4. Okay, so the total there, the total number of atoms in that molecule is 7. Okay, so 2 hydrogens, 1 sulfur, 4 oxygens. We've got 7 atoms in there altogether. Let's look at this one over here, CH3COOH. So how many carbons do I have? Carbon times, well, there's actually one over here, and there's another one over here. So we've got 2. H, how many H's do I have? H3, so that's 3. Oh, but there's another one over here, so times 4. And how many oxygens? Well, they're right next to each other, so oxygen times, we've got 2. Okay, and so the total there is 2 and 4 is 6, another 2, 8. We've got 8 atoms total in that molecule there. Okay, alright, let me clear those ones. Going on to the next example, guys. These ones down here, Na2NO3 is sodium. We've got 2 sodiums. Okay, nitrogen, N, we've only got 1 of those. And O, oxygen, how many of those we got? 3. Okay, add that all up. 2, 1, and 3 is 6. We've got 6 atoms total in there. Now here, lead, remember it's Pb, it's a little b, so that's lead rather than phosphorus and boron. We've got 1 of those, 1 lead. And here I, for iodine, we've got 1 I. Sorry, we've got 2 I's, a little 2 there. So the total there is 3. And you could even name this one, lead iodide. Here, sodium, nitrogen, and oxygen, sodium nitrate, sodium nitrate. So just doing a bit of naming on the way. So guys, I hope that helps. It's not too tricky, but there is one more example we need to go over, a couple more examples we need to go over, because there are a couple of questions you get that could just be a tiny little bit more tricky. So we'll just cover those to make sure you're confident doing those ones too. Okay, so guys, the last bit we need to look at is when we've got brackets to deal with. So brackets, again, are something that sometimes scares students a little bit. They are a little bit more complicated, but it's not that bad, guys. So brackets, guys, you treat elements inside the brackets like a group. So in this case, the 2 outside the bracket indicates that there is 2 of everything inside the brackets. So it means there's 2 hydrogens, but it also means there's 2 oxygens. Now one tip I can give you here is some students find it easier to kind of write it out. So if there's OH2, I might draw in another OH and scribble out my 2. So I've got copper and I've got 2 lots of this OH. So maybe that helps. Or some students, what they like to do is times everything inside here by 2. So put a 2 in front of the O and a 2 in front of the H, and again then get rid of this one. Alright, and then work it out. So if either of those helps, feel free to do that. But basically, guys, what you can see here is we've got 1 copper and we've got 2 of everything inside the brackets. So we've actually got 2 oxygens and 2 hydrogens. 1 copper, 2 oxygens, 2 hydrogens. Okay, let's look at a few examples. Maybe that'll help. So, how many atoms do we have in each of the following? So the first one, aluminium, I've just got the 1. And now I've got OH3. So I could draw in another couple of OHs in brackets like this. So that's what the 3 is telling me. I've got 3 lots of OH, and now I scribble out the 3. Okay, so now I can see I've got 3 oxygens and 3 hydrogens. Alright, or you might find it easier, some students just like to do it this way. You can times everything in the bracket by 3. So 3 oxygens, 3 hydrogens. And then get rid of the 3 because we've used it up. Okay, so either way, you should be able to figure out that we've got oxygen times 3 and hydrogen times 3. Alright, so everything in there times 3 gives us a total of 7. Alright, let's look at this one over here. Copper and sulfur and oxygen. So copper sulfate. Copper sulfate. Copper, we've just got the 1. Sulfur, well there's no bracket there, so sulfur's just on its own there too, 1. And then oxygen with a 4, so we've got 4 oxygens. So the total there, 6. 6 in copper sulfate. Okay, alright, so do you see the difference between the brackets? Here, 3 times everything in the brackets. Here it's just 4 oxygens. It's not 4 of everything. Alright, let's look at a couple maybe more tricky examples. Okay, so this is probably as hard as it would get. So guys, if you can do these, you should be proud of yourself. This is probably sort of as hard as it would get. Alright, this one here, look, aluminium. We can see we've got 2 of those. And again, now we've got the SO4 with the 3 outside. So again, I could draw it like this. SO4. And put another one. We need to have 3 of them. So the 3 is just telling me I've got 3 lots of that SO4. So if I do it this way, how many sulfurs do I have? Well, I've got 1, 2, 3. Sulfur times 3. Sorry, I did my aluminium there. I shouldn't have done it quite like that. Aluminium, we had 2 of those. Okay, and oxygen, we've got 4 and another 4 and another 4. So that's actually 12. Okay, so we can add that all up. 2 and 3 is 5, plus 12 is 17. Now I'll run through that one again, doing it the other way. So again, we can go aluminiums. We've got 2 of those. And now this time I'll do it the other way, times everything in here by 3. So sulfur, we've got 3 sulfurs. And we've got 4 oxygens in there, times by 3. 4 times 3, oxygen is 12. So there's 4 inside, 3 lots of 4 is 12. So here again, 2 and 5 and 12, same answer, 17. Alright, fantastic. Let's do the other one over here. So, magnesium, nitrogen, oxygen, magnesium nitrate. Okay, magnesium nitrate. So just going over that naming again. The other one was aluminium sulfate. Okay, got the oxygen in there too. So, okay, let's go over that one. Magnesium, we've just got 1 of those. There's no number there. Now, in the brackets, NO3, 2. So again, doing it my first way. So magnesium, we've just got 1. NO3, we treat that whole thing as a group because it's in brackets. And the 2 tells me I've got 2 of those groups. So I could draw it out like that and just show that I've got 2 of those groups. So we can see here, how many nitrogens have I got now? Nitrogen times 2. And oxygen, well, I've got 3 there, and another set of 3 would be 6. Okay, so the total there is 9. Just adding those up. 1 and 2 is 3, plus 6 is 9. Okay, do it one more time, do it the other way. So magnesium, I've got 1 of those, times everything in here by 2. So 2 lots of nitrogen, well there's only 1 there, so that would be nitrogen with a 2. Nitrogen times 2. But then 2 times oxygen, well we've got 3 oxygens in here, so it's 2 lots of 3 would be 6. So that would become 6. Would be oxygen times 6. So we add that all up again, and yep, same answer, we've got 9. Okay, so I hope that helps. I hope maybe that's a little bit clearer how to interpret those formula. If you get really big ones like this, we won't get you to draw those. It just takes too long. And it's a bit complicated in terms of how do you draw it, what goes in the middle and things like that. I don't think we'd be that mean. But we could ask you just to work out or tell us how many of each atom is in there, each type of atom, or how many atoms total have you got in there. Okay? Alright, so hopefully that helped. Basically, guys, that's it for formula. So hopefully now you can write some formula, and again, it's just following some basic steps or learning those basic principles, and then you can pretty much apply it to any formula. Okay? So guys, good luck with that. I hope it helped. And that's basically it.